Hi folks, it's Alan here, and I'm just going to do a slightly longer format video about this thing, which is my supercapacitor charger. Now, basically what's going on here is essentially I'm powering a load, which in this case is just 2 resistors, so it's currently taking about half an amp. It can cope with a lot more, but it's powering that load from one of 2 capacitor banks here. And one capacitor bank, it's a bank of supercapacitors, 7 farads in total, and one of them will be permanently powering the load, and the other one will constantly be on charge. So what happens is, if you could just about see these LEDs in here, there's basically 4 little LEDs. You can see 2 of them are lit at the moment around these relays. You'll probably see them switch over in a second. But basically this bottom LED here at the moment, when that is on, it indicates that this relay is turned on, which is the relay that says that this capacitor bank here is currently being charged. You can see actually they've just switched over. So now this relay is on, which means that that capacitor bank now, instead of being on charge, is now powering the output stage, and actually the other capacitor bank is now on charge here. And in a while that'll swap over again. But the other thing that's worth looking at as well is just down here there's another little LED just near this charging circuit, and when it actually does the swap over, that LED will show that the capacitors are being charged. Now what happens is that this is designed so that when the capacitor bank gets below about 16.5 volts, that's no longer deemed as safe to supply the current output, which is a 15 volt output. So what should happen is, very briefly, in the next few seconds, these will change over again, because that's just going to have exceeded drop below 16.5 volts. And when that finally goes, there you go, it goes. And you can see here this LED has come on, which basically shows me that my charging circuit here is now dumping power into the second capacitor bank, or in this case actually this capacitor bank, at a steady 3 amps in order to charge it fairly quickly. Now that basically means that I can make sure that the capacitor banks are well charged before the load switchover happens. There's also lots of safety features involved in here, because the kind of thing you really don't want to do is you don't want to short circuit some of these capacitor banks. And the observant amongst you will have also noticed that there's 2 large capacitors actually in the output side of the circuitry as well. So what's going on there? I mean, yeah, there's a bit of smoothing provided by those, but that's not actually their main purpose. The main thing is it takes a finite period of time for these relays to switch over. And in fact, it's a little more complicated than that, because if I just switch the relays under full load, it'll really shorten their life and it'll weld them shut eventually. So actually what happens is that during the switchover, I disable the charging circuit, switch over the charge relays, and I actually also disable the output circuit, or part of the output circuit here, in order to switch the output relays not under load as well. And the downside of that, of course, is that would mean that you switch the outputs off. So actually these 2 reservoir capacitors, 20,000 microfarads in total, are there just to hold the output voltage up for the few fractions of a second that it takes for this whole switching process to take place. And hey presto, once that works, the output voltage is then re-regulated, again using a series of, I'm using LT3045 regulators here, 6 of them in parallel, to give me really low output impedance, but also to give me extremely precise and about 3 amps, maybe even 4 amps peak capable output power. So basically, with all of these things going on, I think actually what I've got on my hands here is an absolutely fantastic circuit, and it completely isolates the charging side, the main side, from the output side. So what you've got is a totally isolated power supply. It's just like running your HiFi equipment off batteries, but you never have to charge the batteries. It does it all for you.